Okay, so today we're going to talk about abstract classes. Recently, we were talking about a bank account class. And so you'll see here that we've got a bank account. It's got a balance and a name, some constructors, some getters, and then we've got deposit, withdraw, and to string. We made subclasses of that called checking account and called savings account, which had their own separate pieces. Now, if I asked you, do you have a bank account? Most of you would probably say, yes, of course I have a bank account. My next question would be, what type? And you would probably tell me that you have a checking account or a savings account. Nobody really has a bank account. A bank account is this kind of larger idea, this abstract concept that we talk about, but people have more specific versions of a bank account. They've got a checking account or they have a savings account. Not oftentimes now we don't go to the bank and say, I'd like to open a bank account, because the first question that we get asked is, what type of bank account would you like to ask to open? So this concept of a bank account um, is a is an abstract idea where the concrete versions of it are checking account and savings account. So one of the things that we want to make sure people don't do is that people don't try to create a bank account, because it's really not a real thing. However, in terms of programming, it makes sense that we make it a real thing, because then we can utilize inheritance as we implement checking account and savings account to get these variables, the constructors, and all of the methods that we've written inside the bank account class. So if I come over here into my class tester and I write bank account B equals new bank account. Bank account is just a class right now. It's super class. What's going on here? Oh, I got to send in sorry. I've got to send in a string at least. So we'll send in bank account, um, Big Bird. We'll make Big Bird's bank account. Um, so there's not a problem here. Bank account is just a regular class. Everything's fine, and I can do this, and everything's great. Um, but again, I'm allowing people to create a bank account object, which really doesn't make sense, because a bank account isn't a thing. It's this generic idea that we're really using just for inheritance. So I don't really want people to be able to create a bank account. So what we're going to do is we're going to come back into the bank account class, and we're going to add this word abstract. And what we're saying when we add that word abstract is that we're using this as an idea, as this overarching concept, and we're going to use it for inheritance, but I don't want anyone to actually be able to create a bank account object or instantiate a bank account. You'll notice immediately in the class tester over here, we have an error that's happened, because now it tells us you cannot instantiate the type bank account. And the reason that we can't do that is because we have made it um, abstract. Notice that we can still declare a variable as bank account. We just can't call the constructor overtly. Now I can make this a checking account if I want to, and a checking account needs to take a double also. So we'll send in 100. And that's okay. So I can still store my checking account in a bank account variable. I just can't call the constructor and actually instantiate a bank account. Nothing else happens or changes inside of checking account and savings account. They're all still fine. Everything's going great. Inheritance will still work. Polymorphism will still work. The only thing that we've done by creating this bank account class as abstract is prevented people from creating a bank account or instantiating a bank account. Okay. All right. Let's look at another example that we've seen recently. And that is in our zoo project, we had this animal class. So an animal has a name and a sound, and we have our constructors, and we had our get name and our get sound and our to string function. And then we of course had our camel class, which extended animal and sent in a name and a sound. And we had our cow class, which also extended animal and sent in a name and a sound. Now, animal, again, is one of these kind of big ideas. but I want my animal to be able to do something else. And so we're gonna put an eat method in here. So it's just gonna be public void eat. Now, um, how does an animal eat, or what does an animal eat? That's kind of a loaded question. Kind of like, do you have a bank account? Each animal eats its own type of way or its own type of material. Camels eat straw, cows eat grass, um, lions eat meat. So defining the eat method at the animal level doesn't really make sense. So, but I want it there for inheritance purposes. So what we're going to do is we're going to get rid of the brackets here, and we're going to declare this method as abstract, and we're going to put a semicolon after it. When you declare a method as abstract, it does not get any implementation. And so what that means is that it does not get any curly braces, it doesn't get any returns, it doesn't get anything. So public abstract void eat. Now we've got an error here because when you're in a class and you declare a method as abstract, then the class it's in also has to become abstract. So now I've got this abstract class animal, okay? And we also have found errors here in camel and cow. Now that didn't happen before when we were working with bank account, savings account, and checking account, but there's something different now. And what's different is this method, public abstract void eat. See, this class, when I made it abstract, when I made the class abstract, I also have in it this abstract method. So that makes a little bit of a difference. So let's come over to cow and we'll take a look at cow and let's see what the error says here. And the error says the type cow must implement the inherited abstract method animal.eat. All right, so what we've got here is we have to implement that method. We have two choices. I can either implement the eat method or I can make cow an abstract class. Well, I don't want cow to be abstract. So I'm going to have to come in here and I'm going to have to implement the eat method. So it's going to be public void eat. It's got to match it exactly. And then I'm just going to system.out.println the cow ate grass. It just has to have a body. A body can even just be a comment. I don't have to write system.out.println. I can just say the animal or the cow ate, even just as a comment. I don't have to have anything particularly there, but I have to implement the method and it's got to have a set of braces. And at that point, now I have met the condition of inheriting from an abstract class. So the same thing's going to be true in camel. I'm going to have to come down here and I'm going to have to write public void eat and just say camel ate. Doesn't matter what it ate, but I've implemented it. And so now at this point, everything's okay. So I guess the question becomes, why bother? Why make this abstract method eat if I'm going to just have to implement it inside camel and cow anyway? And the answer to that question comes when we start looking at the tester. So let's come in here and let's make a camel cam equals new camel, and our camel constructor needs to take a name, a sound, and a number of humps. So the name will be Cameron, and the sound will be Larg, and the number of humps will be 2. Everything's great, and we'll make a cow. Bessie is a cow, and we'll name her Bessie, and she, of course, says moo. And I can do cam.eat Not surprising. And I can do Bessie dot eat, and everything works, and that as it should, because that eat method is written into the camel and the cow class. If I were to try to make an animal, keep it generic, we of course get the same error that we've always got, and that is that I can't instantiate this because animal is an abstract class. Great. Okay. So let's make an array list of animals. For java.util array list. And so I'm going to make an array list of animals. So we go array list of animal. And that's okay, once again, because I'm allowed to declare things as type animal, but I am not allowed to instantiate them as type animal. And so what we're going to do is we're going to do list.add cam, and we're going to do list.add Betsy. Now, when things come out of this list, when I do system.out. Or when I do this, when I do list.get0, that thing that's coming out, remember, is coming out as an animal. And so if I run the .eat function on it, I'm not getting an error right now. And the reason that I'm not getting an error is because um, because the compiler is looking into the animal class and it's seeing that it has an eat method. Now, if I take that eat method away and I come back here, I automatically get an error there, which means I would have to take this thing and cast it as the type of animal that it is, and it's a camel, before I could call the eat method, right? And so that becomes a little more than I really want to get into. So by having the abstract method inside animal and forming that contract that says any subclass of this animal class is going to have this method implemented, then the compiler will allow me off of an animal object, an animal type variable, to call an eat function, and polymorphism will then call the most local version of that eat function. In a camel, it will call the camel's eat function. In a cow, it will call the cow's eat function. See, if I run this and I run it like this, it just says the cow ate some grass. Okay. And that's because up here I called Bessie.eat. So let's comment these out for a second. Run that again, and you'll see nothing comes out. But if I change this to get1.eat, now it says the cow ate some grass because this thing is coming out in an animal variable and calling eat, but it's calling the cow's version of eat. And it's having that abstract method in that abstract class that is allowing the compiler to call the eat function off the thing coming out of the array list. So that's a look at abstract classes. I hope you found this tutorial helpful.